Okay, so we did start this last time, 2, 3. So we talked about standard form some more. We did solve for y to put it in slope-intercept form. So some of you on your warm-up did try to do that, and that's okay as long as you do that right, to graph your line. But if it says find the x and y intercepts, then you still have to do that. Okay. So it might be easier if it says find x and y intercepts, just start with that. Now if it tells you to put it in slope-intercept form, then obviously you have to do that. So slope-intercept form was y equals mx plus b. Vertical lines don't fit that form because they are only x equals and their slope is undefined. Okay, if I look at this equation, I started with this line, I changed it to slope-intercept form, and then I graphed. So by graphing, you start at your y-intercept and then use your slope. So up 3, right 4. And that's where we left off on Thursday. Okay, so we're ready to start this example. We're given these 2 points, and we want to find slope-intercept form. So first of all, I need to know what slope-intercept form is. So what do I want to plug in here? For what variables, anyway? I want to plug in a number for okay. I want to plug in a number for m and b. Okay. So I want to find the slope and the y-intercept. Well, I have 2 points. Are either one of those points the y-intercept? No. How would I know if I had the y-intercept? Yeah, the x would be 0. So I don't know b. I don't know, but I can't just use 7 or -3. Neither one of those are the y-intercept. So I don't know b. What about the slope? I'm not given it, but I can find it because I have 2 points. So I can do my y2 minus y1. So -3 minus 7 over x2 minus x1. So that's -10 over 2. Okay, -10 over 2 is -5. We all get that? Okay, so in Algebra 1, you learned to take your slope and then take one of your given points and use point-slope form, and then change point-slope form to slope-intercept. We will talk about point-slope form in just a minute, but for now I'm going to show you a way that we can bypass point-slope form and we don't have to remember that one as well. So I have y equals mx plus b, and I have 2 given points. So I could choose either one of those points, and I can plug them in for x and y in my equation. So I can plug in x, y, and m, and then solve for b. So 7 equals -5 times 3. So I'm plugging in 3 and 7 for my x and y. And then -5 for my slope. And now I'm going to solve for b. Okay, so I get that's -15 plus b. Add 15, 22. Let's see. And then write your equation. So go back and write the equation, only plugging in the numbers for m and b. So y and x, when you write an equation, always say y and x. So y equals -5x plus 22. questions about how we did that? Again, we're going to talk about point slope form, but if that's something you have trouble remembering or you just like doing this better, I think this way is easier, then you can do it this way. Alright, point slope form. Y minus y1 equals m parentheses x minus x1, where you're given a slope is m and a point. If you're given a point, that's your x1, y1. So using the information from our previous problem, where the slope is -5 and the point is 3/7, find the point slope equation. So now I'm doing point slope and graph. So point slope, y minus y1 equals m parentheses x minus x1. So -5 is m. My given point is x1, y1. So I have y minus 7 equals -5 parentheses x minus 3. So like when you saw the negatives in the form for circles, if you have a negative here in a formula, that means opposite. So that's your point slope form. When we go to graph it, you graph it the same way as slope intercept, but instead of starting at the y-intercept, you start at your given points. So this is where I start. So I start at 3/7. And then my slope is -5. And when I go to graph it, I want that as a fraction. So -5 over 1. So what directions do I move then? Okay, down 5, and then right 1. Remember, if you run out of room, you could always do opposite and go up 5 and left 1. In this case, it's better to go down. So down 5, right 1. At least 3 points, okay, when you go to graph these. On your quiz, I can give you a ruler. I want nice straight lines all the way through your graph. They're continuous, so put arrows at the ends. Okay? So let's go ahead and change this to slope-intercept form so we look at that again. So slope-intercept form, y is by itself. That's the main point of slope-intercept form, is that it's y equals. So that's all I'm going to do, is just get y by itself. So to do that first, though, I want to distribute over here on the right. And then I need to add 7. So that is where I get my -5x plus 22 again. So this is what we got on the previous page, but You could do it the other way too by solving for b, but this is how to do it using point slope form. This is what you learned in Algebra 1, so this might be more familiar to you. Okay? Okay, parallel and perpendicular lines. So we've already talked about parallel and perpendicular slopes. So now we're going to be writing the equations of parallel and perpendicular lines. So these are the steps. Feel free to summarize or, not write down what you don't need to write down. Just make sure it makes sense to you. So if you're going to write a equation of a line that's parallel or perpendicular to a given line, then what makes it parallel or perpendicular is the slope. So you need to find the slope of the given line. So they just noted that M1. Okay, so the given line will just say, okay, that's our first slope. It doesn't say anything about the y-intercept of the given line. So our y-intercept doesn't matter. Of the given line, we don't care what the y-intercept is. Once you know the slope of your given line, then you want to decide the slope for your new line. So if it's parallel, the slope would be the same. If it's opposite reciprocal, or if it's perpendicular, then it would be opposite reciprocal. And so we just call that one M2. So that's what the parallel perpendicular relationship is. Parallel, it's the same. Perpendicular, opposite, reciprocal. Okay, so use this new slope, M2, with a given point. So you're going to be given a given point x, y. So you're given a new point. Okay. And then solve for b. Or use point slope form. Okay, you can use point slope form too. You want to write your equation in slope intercept form, so whatever way you do that, by solving for b or doing point slope form first, is fine. But the final one should be in slope intercept form. So it'll be our new slope, and then whatever we got for b. Y equals mx plus b, so m2x. Okay. So find the equation of the line using the information given. Write answers in slope-intercept form. So I want my final answer to be y equals mx plus b. Okay, step 1, identify the slope of the given line. Okay, here's my given line. What form is that? Standard. Can you look at it and just know what your slope is right away? No. So you have to change it to slope-intercept form, solve for y, so you know what your slope is of the given line. Okay, I can't do the parallel line without knowing what the slope is of the given line. So I'm going to solve for y. Subtract 6x. And I know slope-intercept form is mx plus b, so I'm going to write the negative 6x first, and then that's positive 27. Divide everything by 9. Okay, make sure you do a reduced fraction, no improper or no mixed numbers, sorry. Improper fractions if necessary, no mixed numbers, no decimals here. So negative 6 divided by 9 is negative 2/3 x. Okay. And remember I said the y-intercept of the given line doesn't matter, so I don't care what that is. I mean, just as a practice, it's 3. We know we divide by 3, or 9 again. But all I really care about is the slope. So the slope of my given line, or we just said was m1, is negative 2/3. So all that work was just to find the slope of the given line. Okay, step 2 says now find the slope m2 of a new line using the parallel or perpendicular relationship. So it depends on what it asks you to find. It wants the parallel. Okay, so my new slope, if the lines are parallel, then the slopes are the same. So what would I use for my new slope? Negative 2/3. What if it said perpendicular? What would you use for your new slope? 3/2. Good. Okay, so that's all I had to do for step 2. Step 3, use M2 with the point xy. So here's my given point. Here's my xy. And the formula y equals mx plus b, and solve for b. So my given point was negative 3, negative 5. And then this is my m.
This is Cecil.
Yes?
Would you just Colton Group to student administration, please?
Yes?
Thank you.
So negative 5 equals negative 2/3 times negative 3 plus b. Negative 2/3 times negative 3 is positive 2. Subtract 2, so I get negative 7 equals b. And our fourth and final step is to write it in slope-intercept form. So y equals negative 2/3 x minus 7. So remember, on this step 3, you could have used point slope form as well. Questions about that? So it's a little tedious, it takes a little bit of time, but as long as you follow the steps, then you shouldn't have any problems. So not that you need to write the steps down every single time, but at least mentally going through what you're doing. So find the given slope, identify the new slope you need to use, solve for b, and then write your equation. In Algebra 1, I have students struggle here. They would find the new slope, but then they would maybe use the same y-intercept, or they would just use negative 5, because that's the y-coordinate. Okay, so keep in mind what you're doing the whole time. Okay. A right, is a line that intersects a graph at 2 or more points. So for the given graph, find the equation of the line parallel and perpendicular to the secant line through the point indicated. So a secant line is a line. So in this picture here, the blue, the line, this is the secant line, and it's intersecting this graph, what's in red, in 2 points. So that's what makes it a secant line. It intersects at 2 or more points. So this is the point -2, 2. This is the point 3, 0. The point indicated, this is this extra point right here. 1, 3. So through 1, 3, I'm going to draw a parallel line. It doesn't ask me to graph it, but just so we know. I have a parallel line. I'm going to find the equation of that parallel line, and then the perpendicular line. So that's what I'm trying to do. Okay, so if I go through the steps, I need to have first the slope of my given line. Well, I know 2 points, so I can use the slope formula. Or since I have a graph, I can just count rise over run. So if I work left to right, I start here, I went down 2, and then right 1, 2, 3, 4, 5. So down 2, -2, right is positive. So down 2, right. Remember, I don't care what the y-intercept of my given line is, so that's all I had to do here. I also could have done the slope formula. 0 minus 2 is -2. 3 minus -2 is positive 5. Okay, so first of all, I need parallel. Okay. So if I want the slope that would give me a parallel line, I would use -2/5. Same slope. If I want perpendicular, say M2, sorry, then I want M2 to be +5/2. Good. Okay. So let's do parallel first. My given point, though, is 1, 3. So that's my given x, y. And y equals mx plus b. So 3 equals the parallel slope that I want to use is -2/5 times 1. And solve for b. So you do 3 plus 2/5, 17/5, don't you get? Okay. Alright, so you can write that equation if you want to go ahead and finish up parallel. Y equals negative 2/5 x plus 17/5. Let's go back here and do the same thing with perpendicular. So 3 equals 5/2 times 1 plus b. Okay. Subtract 5 halves, so 3 minus 5 halves. B equals 1/2. Okay. All right, and then that equation y equals 5 halves x plus 1. You're given a graph, so make sure it makes sense. Okay, so this is a little over 3 here on parallel. So 1, 2, 3. Yep, that looks like I started my line intercepts a little over 3. Okay, and the slope is the same, so down to right 5. Perpendicular, so the other one, this line's not drawn as good. It should be here, 1/2, but then it should be opposite reciprocal, so up 5, right 2. That's what you want there. Okay. Questions about that? Do we understand what a secant line is? It's a line that goes through a graph, and it goes through 2 or more points. So this line here, this parallel line, this is not a secant line because it only goes through once. So we're going to talk about slope a little bit in a word problem. So slope represents rate of change. So n equals, remember that triangle is delta, so delta y over delta x means the quantity measured along the x-axis is changing with respect to changes quantity in the quantity measured along the x-axis. So the change in y over the change in x. So you're comparing the changes in y to the changes in x. So x is going to, when you read a graph, you read it left to right. So you always look at how x is increasing, and then what's y doing? Is y going up? Is y going down? So when you read about variables being a function of another variable, so we don't really go into functions until 2.4. But when we say temperature is a function of height, so that means this is your y variable. Temperature is your y, height is your x. So it's a function of height. So as height changes, what is temperature doing? And you'll see it written like this, T of H. So remember, this parentheses is like saying of, so T of H. It's y as a function of x. All right, so I want to look at this problem, and we're not going to go through and do every single part. We're going to talk about them. Okay. Well, the problem is pretty short, right? It just stops right here, and then there's questions to ask. Okay. So retail sales of prescription drugs have been increasing steadily in recent years. In 1995, retail sales hit $72 billion. By 2000, sales had grown to about $146 billion. So use the relation year, comma, retail sales of prescription drugs. So this is my X and Y, but they're calling it T. So with T equals 0 corresponding to 1995. So this is 0. So T is our years since 1995. And then I have what other variable? You don't have to give me a letter. What else needs to be represented? The sales, right? So I have my years, and now I have need sales. So it doesn't matter. They use T, so I'll just use S is sales. And I'm going to say in billions. So then I don't have to write, 9 zeros after that. I can just write 72. Okay. So write a linear equation. So I'm going to use like mx plus b. So do I know what? Well, let me write out our two ordered pairs that we're given. So we're given 0, 72. Okay? And then I also know in 2000 sales had grown to 146 billion. So how would I write that? 2000 is how many years since 1995? 5. And then it was 146 billion. Okay. Do I know my y-intercept? Yeah, so I don't have to solve for b or new point slope form. I know what the y-intercept is. It's 72. But I still need to find the slope. So 146 minus 72 over 5 minus 0. I'll go ahead and calculate this for you because we're running short on time. 74 over 5. So then my equation, the sales are 74 over 5t plus 72. Do we see that, how we got the equation there? Okay, describe what this slope indicates in this context, or discuss what the slope indicates. So this is where we're going to take a deeper look at what 74 over 5 is. So 74 over 5, I'm going to go ahead and find out what that is in a unit rate. So I'm going to divide, and that's 14.8 over 1. So the reason why I do that is because I'm going to try to look per year here. So the 74 was the y, the change in y. And what's our y variable? What's the y variable represent? Sales. And then the 5 is on the bottom. What's the x variable represent? Years. So really, I can say that my sales are increasing, because it's positive, $14.8 billion per 1 year. So do we see how we got that? So you know how to find slope in 74 over 5, but we don't spend a lot of time talking about what it actually means. It's your change in y over change in x. So the change is 14.8 in y, and then 1 for x. So sales are increasing by $14.8 billion per year. The rest of the questions, I can just use my equation. So I can plug in what year will sales reach 250 billion. That goes in for S. And then I want to know, here's a year, but year since 1995, I would be plugging in 10. Okay. All right, so we'll stop there. That takes us through enough of 2-3. We're good to go now. So then tomorrow we'll be practicing the problems. Start tonight. It'd be a great idea to start tonight looking over stuff.